Hello friends, in the last lecture we learnt about the positive and negative logic, the timing diagrams, the truth table, various traditional and IEEE standard symbols of gates, and mainly we discussed the NOT and the AND gate in detail along with their applications. In today's lecture, we shall be talking about the OR gate, NAND gate, NOR gate, and finally, the exclusive OR and the exclusive NOR gates. The OR gate. The OR gate is another of the basic gates from which all logic functions are constructed. An OR gate can have two or more inputs and one output as indicated by the standard logic symbol in figure and performs what is known as the logical addition. An OR gate can have any number of inputs greater than 1. An OR gate produces a high on the output when any of the inputs is high. The output is low only when all of the inputs are low. Therefore, an OR gate determines when one or more of its inputs are high and produces a high on its output to indicate this condition. The figure here illustrates the operation for a 2-input OR gate for all 4 possible input combinations. As shown in the figure, the inputs of the 2-input OR gate are labeled A and B and the output is labeled X. The operation of the gate can be stated as follows. For a 2-input OR gate, output X is high when either input A or input B is high, or when both A and B are high. X is low only when both A and B are low. The high level is the active or asserted output level for the OR gate. OR gate truth table. The operation of a 2-input OR gate is described in this table. The truth table can be expanded for any number of inputs, but regardless of the number of inputs, the output is high when one or more of the inputs are high. Operation with waveform inputs. Now, let us look at the operation of an OR gate with pulse waveform inputs, keeping in mind its logical operation. Again, the important thing in the analysis of gate operation with pulse waveforms is the time relationship of all the waveforms involved. For example, as shown in figure, input A and B are both high during the time interval T1, making output X high. During time interval T2, input A is low, but because input B is high, the output is high. Both inputs are low during time interval T3, so there is a low output during this time. During time interval T4, the output is high because input A is high. Logic expressions for an OR gate. The logical OR function of two variables is represented mathematically by a plus between two variables. For example, A plus B. Addition in Boolean algebra involves variables whose values are either binary 1 or binary 0. The basic rules for Boolean addition are as follows. Boolean addition is the same as the OR function. Notice that Boolean addition differs from binary addition in the case where two ones are added. There is no carry in Boolean addition. The operation of a two input OR gate can be expressed as follows. If one input variable is A, if the other input variable is B, and if the output variable is X, then the Boolean expression is X is equal to A plus B. Figure shows the OR gate logic symbol with input variables and the output variable labeled. To extend the OR expression to more than two input variables, a new letter is used for each additional variable. For instance, the function of a three input OR gate can be expressed as x is equal to a plus b plus c. The expression for a four input OR gate can be written as x is equal to a plus b plus c plus d and so on. As shown in the table, OR gate operation can be evaluated by using the Boolean expressions for the output x by substituting all possible combinations of 1 and 0 values for the input variables for a two input OR gate. This evaluation shows that the output x of an OR gate is high when any one or more of the inputs are high. A similar analysis can be extended to OR gates with any number of input variables. An application. The figure here shows a simplified portion of an intrusion detection and alarm system. This system could be used for one room in a home, a room with two windows and a door. The sensors are magnetic switches that produce a high output when open and a low output when closed. As long as the windows and the doors are secured, the switches are closed and all three of the OR gate inputs are low. When one of the windows or doors is opened, a high is produced on that input to the OR gate and the gate output goes high. It then activates and latches an alarm circuit to warn the intrusion. The NAND gate. The NAND gate is a popular logic element because it can be used as a universal gate. That is, NAND gates can be used in combination to perform the AND, OR and inverter operations. The term NAND is a contraction of NOT AND and implies an AND function with a complemented or inverted output. The standard logic symbol for a two input NAND gate and its equivalency to an AND gate followed by an inverter are shown in figure. A NAND gate produces a low output only when all the inputs are high. When any of the inputs is low, the output will be high. For a specific case of a two input NAND gate, as shown in figure, with the inputs labeled A and B and the output labeled X, the operation can be stated as follows. For a two input NAND gate, output X is low only when input A and B are high. X is high when either A or B is low, or when both A and B are low. Note that this operation is opposite that of the AND in terms of the output level. In a NAND gate, The low level is the active or asserted output level as indicated by the bubble on the output. The truth table summarizing the logical operation of the two input NAND gate is shown in this figure. Inherent in a NAND gate's operation is the fact that one or more low inputs produce a high output. Table here shows that output X is high when any of the inputs A and B is low. From this viewpoint, a NAND gate can be used for an OR operation that requires one or more low inputs to produce a high output. This aspect of NAND operation is referred to as negative OR. The term negative in this context means that the inputs are defined to be in the active or asserted state when low. So, the conclusion is for a two input NAND gate performing a negative OR operation, output X is high when either input A or input B is low, or when both A and B are low. When a NAND gate is used to detect one or more lows on its input rather than all highs, it is performing the negative OR operation and is represented by the standard logic symbol shown in this figure. Although the two symbols in the figure represent the same physical gate, they serve to define its role or mode of operation in a particular application. Logic expression for a NAND gate. The Boolean expression for the output of a two input NAND gate is X is equal to AB bar. This expression says that the two input variables A and B are first ANDed and then complemented as indicated by the bar over the AND expression. This is a description in equation form of the operation of a NAND gate with two inputs. Evaluating this expression for all possible values of the two input variables, you get the results as shown in this table. Once an expression is determined for a given logic function, the function can be evaluated for all possible values of the variables. The evaluation tells you exactly what the output of the logic circuit is for each of the input conditions, and it therefore gives you a complete description of the circuit's logic operation. The NAND expression can be extended to more than two input variables by including additional letters to represent the other variables. The NOR gate. The NOR gate, like the NAND gate, is a useful logic element because it can be used as a universal gate, that is, NOR gates can be used in combination to perform the AND, OR and inverter operations. The term NOR is a contraction of NOT OR and implies an OR function with an inverted output. The standard logic symbol for a two input NOR gate and its equivalent OR gate followed by an inverter are shown in figure. A NOR gate produces a low output when any of its inputs is high. Only when all of its inputs are low is the output high. For a specific case of a two input NOR gate as shown in figure with the inputs labeled A and B and the output labeled X, the operation can be stated as follows. For a two input NOR gate, output X is low when either input A or input B is high, or when both A and B are high. X is high only when both A and B are low. This operation results in an output level opposite that of the OR gate. In a NOR gate, the low output is the active or asserted output level as indicated by the bubble on the output, and this table here is the truth table for a 2 input NOR gate. Negative and equivalent operation of the NOR gate. A NOR gate, like the NAND, has another aspect of its operation that is inherent in the way it logically functions. The table here shows that a high is produced on the gate output only when all of the inputs are low. From this viewpoint, a NOR gate can be used for an AND operation that requires all low inputs to produce a high output. This aspect of NOR operation is called negative AND. The term negative in this context means that the inputs are defined to be in the active or asserted state when low. So, the conclusion is for a 2 input NOR gate performing a negative AND operation, the output X is high only when both inputs A and B are low. When a NOR gate is used to detect all lows on its inputs rather than one or more highs, it is performing the negative AND operation and is represented by the standard symbol as shown in this figure. It is important to remember that the two symbols in figure represent the same physical gate and serve only to distinguish between the two modes of its operation. Logical expression for a NOR gate. The Boolean expression for the output of a 2 input NOR gate can be written as x is equal to a plus b bar. This equation says that the two input variables are first ORed and then complemented as indicated by the bar over the OR expression. Evaluating this expression, you get the results shown in this table. The NOR expression can be extended to more than 2 input variables by including additional letters to represent the other variables. The exclusive OR and exclusive NOR gates. Exclusive OR and exclusive NOR gates are formed by a combination of other gates already discussed. However, because of their fundamental importance in many applications, these gates are often treated as basic logic elements with their own unique symbols. The exclusive OR gate, commonly written as XOR gate, is a 2 input 1 output gate. Figure here shows the logic symbol and truth table of a 2 input XOR gate. As can be seen from the truth table, the output of an XOR gate is a logic 1 when the inputs are unlike and a logic 0 when the inputs are like. The output of a 2 input XOR gate is expressed by X is equal to A bar B and A B bar. The exclusive NOR gate. Exclusive NOR, which is commonly written as XNOR, means not of XOR, that is the logic gate that we get by complementing the output of an XOR gate. The figure here shows its circuit symbol along with its truth table. The truth table of an XNOR gate is obtained from the truth table of an XOR gate by complementing the output entries. Logically, X is equal to A dot B plus A bar dot B bar. The output of a 2-input XNOR gate is a logic 1 when the inputs are like, and a logic 0 when they are unlike. In general, the output of a multiple input XNOR logic function is a logic 0 when the number of ones in the input sequence is odd, and a logic 1 when the number of ones in the input sequence is even including 0. That is, an all zeros input sequence also produces a logic 1 at the output. So, friends, here we come to the end of our discussion in this lecture, and therefore, we sum up. We learned that the OR gate output is high when any of the inputs is high. The NAND gate output is low only when all the inputs are high. The NAND gate can be viewed as a negative OR whose output is high when any of inputs is low. The NOR gate output is low when any of the inputs is high. The NOR can be viewed as a negative AND whose output is high only when all of the inputs are low. The exclusive OR gate output is high when the inputs are not the same. The exclusive NOR gate output is low when the inputs are not the same. So, friends, that is it for today. See you in the next lecture with Boolean algebra. Thank you very much.